introduce our next speaker. Welcome, everyone. I'd now like to introduce Lawrence Udeigwe, who's going to be presenting using student differential equation projects for general public education.
Thank you very much. Thank you. Thank you, Anna. All right. I'm going to start with a summary of my talk. I'm going to share about how I use student final projects in an ODE course to design and educate the public, to design a project that can be used to educate the public. And I'm going to be talking about what the experience was like. And lately, I've been interested in how to frame ethical reasoning in STEM. So I'm going to talk about how, maybe have an open discussion of how we can use this avenue and maybe other avenues to frame ethical reasoning in STEM and mathematics in particular. So what was my motivation? So during the pandemic, we all know that educators and learners were thrown into this situation where we had to figure out new paradigm for learning, and we did different things. Some of them worked, some of them didn't work, and some of them that did not work, we learned from them. And in general, we ended up coming up with very innovative ways of learning, of interacting with students, and of assessing. So that I've always been interested in keeping students motivated to learn mathematics. If you're an educator, you know that this can be challenging sometimes. And if you are a student, we all have been students, and we know that sometimes we can only take maybe we can take 30 minutes out of a 50-minute class. And in a math talk, sometimes we're only able to take the first 1/5 of the talk, and then after that we zone out because it goes into a very deep territory. So I've always been concerned with how can we keep people's motivation, in students in particular. And I'm also interested in how to make math accessible to general public and make them find it fun and groove to it. And I am also interested in how to take advantage of current technology in the teaching and learning of mathematics. So the course that I taught was a differential equations course at Manhattan College. Is called Math 286. And I did this in the spring of 2021. And the learning outcome of the course is it's like a traditional differential equations course, mathematical modeling through differential equations, first order, all the methods of first order differential equations, the methods of second order differential equations, and systems of two linear first order differential equations with constant coefficients. And the textbook we used was a first course in differential equations with modeling by Dennis G. Zill. You can see that throughout the course, we focused on first order and second order differential equations. And since I was interested in giving a final project, I spent time on selecting projects that would introduce the students to first order differential equations and how to model first order differential equations, and also a rich projects in second order differential equations. So throughout the semester, I gave the students two projects. I held their hands through two projects, and the assessment, I used homework, quizzes, midterms, and final exam. And then I chose for the two projects that I gave, I chose them from CMUD, and then I asked them to create a final project, which they allowed to choose from the CMUD bank, okay? So the first project we talked about was population model variation and MATLAB by William Skerbitz. I found this very interesting, a very rich and comprehensive yet approachable and accessible project, because it gives a walkthrough of a detailed derivation of basic exponential and logistic population models and how to create these variations of these models and how to explore and visualize them using MATLAB and Desmos. I introduced Desmos to it, and I also taught the students how they can use a little bit of Python to do certain things. And the class of differential equations that applied that show up in this project were the first order linear, nonlinear, homogeneous differential equations, the analytical techniques, initial value problems, separation of variables, and the qualitative analysis, stability, first plane, graphical analysis. So it's a project that kind of it's almost comprehensive when it comes to the techniques that we see in differential equations. Okay. So these are kind of the details. I don't want to go through that. I feel like we can go to the Semioid project banks and we can find this. And if anybody wants to talk more about it, we can schedule a time to do that. I'll be very happy to go through it. And the second project I looked at was modeling car suspension, which was a project that was a modeling scenario created by Brian Winkle and Teresa Shelton. Why I chose this project was because it introduces students to how second order differential equations are derived, and it also goes into the different scenarios that leads to the dynamics, the different dynamics of second order differential equations, including fixed point dynamics, including oscillations and so forth. Again, it's a rich project that is very encompassing and looked at all the different techniques that can be applied to second order differential equations. All right. So the final project, I told this after the students have seen these two projects and they have gone through it and have visited my office hours several times in order to complete it, I felt like they were ready for their own project. And the goal of this project is to create a modeling scenario that uses differential equations. But the important thing is that it has to be created for a general audience. The goal is to explore a phenomenon that can be explained using differential equations. And the parts, it has to have an introduction and background, and it has to have a clear mathematical exploration and then a conclusion. And then the major rule that I kind of emphasize is that they have to pick a target audience, and the target audience is a high school student. And the job of my class, the students in my class, is to teach these students without intimidating them. How can we introduce a high school student to differential equations without worrying about all the things that they have to know before understanding what we are presenting in the project, even if we have some prerequisites that this high school student has to know before understanding our project. What efforts have we made in the introduction and background to explain this concept in a way that they will understand? And the main product I asked of my students is a 20-minute video recording of their presentation uploaded on YouTube. So I made them work in groups of not more than 4, and they ended up coming up with a bunch of projects that we created a playlist for. And I can send the link to the project after my talk. We only have 20 minutes, so I can't play through all of them, but they chose very interesting projects that they found interesting, and their zeal to keep going in the project kind of actually impressed me, and their ability to look at other places for inspiration outside of the Semioid scenario bank was very impressive also. Okay, so I want to look at some of the audience feedback, some of the people that watched the YouTube presentations. A lot of them, I have to say that a lot of them were friends of my students, because I told them that for each video, they have to have at least like at least 20 audience members, people who are going to watch it and give them feedback. Most of them were not in the class, and some of them were non-math, most of them were non-math majors. So there's a project on evaporation that was presented by a group that called themselves the Calcoholics. They did a project on the evaporation of alcohol. And I can pick out one interesting or one feedback that I found elucidating. It says, I thought I understood evaporation in simple biological terms, but looking at it mathematically and modeling its rate was super interesting. I would definitely like to learn more about it and the different ways to apply this. Even relating back to biology, for example, something like the evaporation of sweat and how it cools us down. So this was a biology major that found our differential equations modeling a project interesting. And immediately she started thinking of how to relate it to biology. And the next one was a group that did modeling of internet platforms. So there was this project modeling, this modeling scenario on the Simiod scenario banks that did internet platforms. But this group focused on cryptocurrency internet platforms. And they went ahead and studied a lot about cryptocurrency. And they did a wonderful presentation on that. And they had a finance major who ended up running into the video and watched it and gave the feedback. She said, this was a very captivating topic for me since I've always wanted to be introduced to cryptocurrency. I liked how you explained Bitcoin in detail to introduce the topic. You did a good job explaining how modeling the differential equations can be used to observe internet platforms. Especially, I like the odd system where you got the eigenvalues to be complex numbers and fixed points become spiral. And then you connected it to the outcome of buyers and sellers. The first portrait looks fascinating. Overall, the presentation was organized and easy to follow. I'm excited to learn more about it. So that's just two feedback that I wanted to highlight. And there are other feedbacks, but I won't worry too much about this because of time for now. But I want to go to my students' feedback. I asked them a bunch of questions about the project because that was the first time I did such a thing. And I wasn't very confident. So I wanted to know, hey, how do they feel about it? So to know if I should encourage other people to do this, or even if I can try it again myself. So I asked them, how did the project help your understanding of differential equations? By the way, I like whenever I look for feedback, I like letting my students just give me feedback in their own words. I don't like the rating system where they rate things from 1 to 5, because sometimes it's easy for students to just give 1, 1, 1 or 5, 5, 5, and then it just end up skewing the response. So I like reading what they write and going through it and taking things back for myself. So if you look at the word cloud, you will see that the biggest words there were equations, differential equations, projects, and you will see that those are not too important because in describing their feelings about the project, they have to use the word differential equations and so forth. But if you look, you see words like real world, real, all over the place. And you can see that when you read their feedbacks, you will see that they're talking about how allowing them design such a project by themselves and explain it in their own words puts them in a position where they clearly see and can also explain to others the importance of differential equations in capturing real-world phenomena. So, sorry. There's one feedback that I found, I picked, this was actually random. I picked a random feedback, this is just one. And she said, the project helped my understanding of differential equations by showing me how differential equations can be used in all parts of life. This was something that was explained to us, but I never really considered how differential equations would be used in the real world. Watching the projects and seeing how the topics were so different and differential equations were still useful in them showed me that even in areas where you expected differential equation to be wouldn't be useful, they are still useful. For example, snails in a pool tide. There was a project about snails in a pool tide and the dynamics of survival of snails in a pool tide. And then I asked the next question, what do you like about the project? Or what do you not like about the project? And their feedback was the time. I didn't give them enough time. And I realized mid-semester that I should have given them enough time, more time than I did. And I should have held their hand closely more because I was throwing them into the river, making them swim because they're dealing with a lot of parameters. The fact that they have to study this things themselves, get feedback about or get introductory materials about the topic they choose, and then incorporate it into a project, and then design a project that is accessible by a high school student. So I thought I should have done, if I do it again, I would start maybe after the third week of class to start discussing this public education project because it's very important. And I picked again a random feedback. And this, when I say random, is out of 56 students. And the students said the only thing that I didn't like about the project was the short amount of time we were given to approach this task and explore it. I wish we had more time to work on it and grasp and analyze it better. Also, to be creative and incorporate our imagination and knowledge of mathematics into this project. Okay, the last one, are there any helpful experience you gained from working on the project? And again, most of them talked about how working in groups helped them and how it's going to help, how they're seeing how they're experiencing in a very short amount of time, in a somewhat restricted environment, which is a differential equations class. They're seeing how they would be working with what they've learned in the real world, for instance. And one student said, overall, the presentation aspect was really helpful because it has you put yourself out there. The feedback from other people on how you did was motivating, and seeing everyone else work to compare how we could do better in the future was thought-provoking. I love that expression. It's good practice because you're going to have to be making a lot of presentations in our college and work career, and this is just a step towards getting better. Okay, so my takeaway was that when I read all their feedback and I went through all the videos and the feedback or the comments, I saw that students show ability to synthesize the multiple facets of mathematics that they learned. Sometimes we feel like our students, after learning things, they abandon it. In giving them this project, I saw that some of the things they learned in Calc 1, they were just using it and they were just effortlessly using it, functionally using it in order to communicate to differential equations to the students that may not have taken differential equations. And so that students showed a great deal of interest in the non-math aspect of the project. We are mathematicians and we want our students to show interest in mathematics. But if we are modelers also, we want our students to be interested in real-world phenomenon so that they can think about how to explore this real-world phenomenon using mathematics and differential equations in particular. And this student showed me that, yes, they know how to, they are interested, or they have this ability to think of non-math things in a math-oriented way. And I noticed that non-mathematics majors show a lot of interest in the videos. Most of the comments were from non-math majors, and even non-engineering majors. A lot of environmental engineering, environmental science majors, a lot of biology majors, a lot of finance majors, and a lot of psychology majors commented. Next time, I will give more time, and there will be mid-project submission and feedback from me to give them, to critique them and tell them how, and figure out the best direction to keep going in the project. So I started thinking about ethical reasoning, because ethics, as we know, ethics is an important concept. And sometimes we as mathematicians, we come from a culture going to grad school where all we did was prove. By the time we come out, forget that we have to worry about things like ethics. So I got involved in this group where we're thinking of how to frame ethical reasoning in a mathematics classroom. So I approached this project that I did, analyze it from an ethical reasoning perspective, and I came up with 4 questions. The 4 questions I came up with is, if I'm doing this, if I'm giving students this task again, what should I be looking at? The first question I would ask is, does the project tackle at least one learning outcome or objective of the course, right? Because even though we're interested in projects that would be accessible to non-differential equations students, we still have to stay within the parameters of differential equations, the parameters of the course. And if it does so, does the project pose an ethical reasoning challenge, you know? So for instance, if we are modeling snails, the habitat of snails, do we consider the ethical questions that may be posed when it comes to dealing with a snail habitat, right? Does the project adhere to the ethical standards of any related fields? Now, for instance, if we're dealing with data in a differential equations course, have the students taken their time to get a fair familiarization of the ethical standards of data handling that a statistician would, for instance, adhere to, or an engineer, or somebody working in the industry would adhere to? Okay, and has the student proven that they've familiarized themselves to a certain extent with these ethical standards? And the next question is, does the project effectively and sensitively address the interest position of each stakeholder? So for instance, if we give our student the task of modeling how maybe we could model a road that passes by a bee habitat, for instance. How there are some people who would be interested in not having the road because they don't want the sound, the noise from the road to disrupt the bee habitat. And there are some others that would want to get from point A to point B, and they will say, hey, we want to get from point A to point B. We don't care about bees. We want to go about our daily business and make a living, you know? So I would want my students to understand that there are stakeholders, there are interests and positions when we are creating models. And the last question is, are enough resources devoted to addressing follow-up questions from the general public? So that is the goal, the task for the instructor. If we're going to do this and we're asking students to help educate the general public, first of all, we have to make sure that whatever the students are putting out there a very correct, mathematically accurate, which is something I failed. I didn't fail at it. I would give myself a C at it because the time was very, very short and it was during the pandemic. So some of the things they presented were not totally accurate, but I'm okay with it for now. But is it accurate? And then if there are follow-up questions, has the instructor found ways to devote resources towards answering these follow-up questions, since our goal is to educate the general public? All right, I would like to acknowledge my 2021 differential equation students at Manhattan College, my Manhattan College colleagues, and Brian Winkle for starting SIMYOD and for being a great mentor throughout the period I've known him. Thank you. I'll answer questions.
Thank you so much. That was wonderful. We do have some time for questions, and this room can also stay open as long as you would like. So for people that want to go to another session, that'll start in 4 minutes. But otherwise, feel free to stay here and ask your questions. We do have to get going though. So Lawrence, you
Yes,
will be in
Carrie.
charge.
Yes, go ahead, Carrie.
Oh, hi, Lawrence. Thank you very much. That was very inspiring.
Thank you.
Very inspiring. Just a clarification question from me. When you did 2 projects with the students yourselves and walked
Yes.
through it, then when it came to the students' final project for the general audience, the students were going and choosing those projects themselves. That was self-choice.
Yes, they chose it themselves. Yeah.
Okay, that's good.
Yes.
And did you give them a list of resources to choose from, or were they just off and finding stuff and then just coming back and maybe checking that they're on?
Yeah.
Go for it.
Yes, they chose the project themselves. But they conferred with me, they kind of consulted me to make sure it's okay and to make sure it's something that they can handle. And we went through it before we concluded on the project. Yeah.
Yeah, nice. Cool. Thank you.
Thank you very much. Who's next? Okay.
I could.
Yes, Greg. Hi.
Yeah, hi. Fascinating talk.
Thank you.
Lots of great ideas.
Thank you very much.
What I found unique about your approach is that students are posting in a public space.
Yes.
And I don't see, I've seen project presentations on projects, and I've done projects before in my courses, but having students post where Brian Winkle can just go in there and comment on is very very unique. And I don't know what to ask here, but I think for example, your survey question, the questions you asked your students for feedback,
Yeah.
is just an idea, I guess, you asking them about that component, because you could have had them maybe post in a space where only the class can view, but you didn't. You posted in a public arena.
Yes.
Right?
Yes.
So
yes.
Something about that. That's really interesting.
Yeah, it was a choice I decided. It was a bold choice that I thought I had to make. And I was prepared to get any kind of criticism, or for the students, for us to get any kind of criticism, because it's going out there, venturing in the wild. But since it's public education, we have to do what we have to do. We want the students to tell other people this is what we learn in our differential equations class, and we want to get feedback from the people to keep improving. And the feedbacks that I read, like this feedback, they were from the students participating in the project, their feedback, their experience and so forth. And none of them thought it was too much of an ask to make them post on a public YouTube like that. Yeah. So
very cool. I could see this being used in any, well, undergraduate math course that has time to incorporate, because it's a general kind of framework, calculus 1, 2, 3. You could ask the
Yep.
students, describe an application, post a YouTube video of 5 minutes, 10 minutes, however long, and share
Exactly.
it with the world, right? It's not just DEs.
Yes, exactly. Thank you.
Yeah, really interesting.
Thank you very much. Let's see, there's a question in the chat. Great project. That help educate and inspire general public. Audience feedback requirements really. Okay, thank you. Thank you very much, Beverly. Yeah. Okay, I'm here. If any other person wants to talk about any other thing.
Yeah. Just thank you, Lawrence. That was great. I'm going to sneak off now, but thank you.
All right. Thank you very much. Take it easy, guys.